It's recording now. Okay. Okay, I want to copy here. I copy the function. Okay, I need to do the graph. This is classical question in the test. The first question is do the graph of any exponential function. I don't know see the base is 2, see the base is 3, see the base is 4, or see the base is... Look, in this case, we have negative exponent. Negative exponent means reciprocal. Actually, the base is 1/2, not 2. Therefore, this exponential is exponential decay. So it's going down, it's decreasing function, no? So you plot the famous 3 point, are the famous point universal 0, 1. I plot that. Boom. The another point is 1, the base, the base is 1/2. 1, 1/2 approximately look like that. And -1 and reciprocal of the base is 2. Reciprocal of the base is 2. -1, 2 here. 3 point is enough. You want more, you can, but it's okay. And we connect this point by the curve approximately. You know the shape of this curve. By the way, -2 is 4. -2 is 1, 2, 3, 4 here. Over there. This is -2, 4. It's another possibility of the point. And don't forget, please, the famous horizontal asymptote that any exponential function have horizontal asymptote at y equals 0. End the story. Done. Question number 1. Any question? Do you follow me? Do you understand? You need some clarification, clarify something? No problem? Come on, guys. This is the review. Because I need answer. Professor is okay. Professor no. Professor explain me something. Hello, Yamin. How you doing? Yamin, how you doing?
Good, Professor. And you?
Yeah, perfect. Any question? Exponential function. We are doing. No problem.
No questions.
Good. Let's move on to the question 2 now. Okay, it's similar, except in the question 2 we have, of course, the base 4. Let's see, the base is 4. The function is 4 to the x. I know that when the base is greater than 1, the exponential is increasing, growth exponential. And the famous points are 0, 1, 1,4, get the base, and -1, 1,4, get the reciprocal of the base. I plot that. The first point, universal point, 0, 1, 1,4 is here. There's a reason it's increasing. And -1,114 approximately, you know, is half of the half, like that. This point is a point, -1,114. We connecting, this case is exponential. Remember, the exponential is asymptotically to the x-axis. I'm increasing super faster. And the reason it's increasing super faster is because the base is 4, que es a big number, no? Now, don't forget the famous horizontals. Okay, it's important the horizontal. So you forgot the horizontal asymptote, you have no full credit. That is basically 3 points at least. And the horizontals. Any question? Any question? No.
No, Professor.
Okay, super. So now for a moment, temporary, we have no more graph. Yes, after we have another graph of the logarithmic. But for the moment, no. Okay, no more graph. Let's move on to the word problem applications. The first one is biology problem. Is the growth in the population fits the exponential function is the function gets given is really noise. Noise. Who making noise? I know. One noise. One. Okay. Okay. Okay, look. Is the growth in the population fit the exponential function? The formula is, I want to copy again. Population to any time is equal to 346, is the initial population, e to the 0.05t. So everything is given. Remember the formula, the general formula is P null e to the kt. P null is 346 in our problem. K is given as 0.05, que is the parameter que indicate how fast increasing the exponential. O sea, it's super easy problem. Entonces, where T is the number of years since 1978, estimate the population in 2011. Okay. Let me try to make a graph to interpretation. Remember, for me, it's good do the graph because one picture is much better than 1,000 word population. Entonces, at the beginning, que es T equals 0, que a specific our application is 1978. We have 346, que es P null, que is the initial, right? Now the population increases exponential. One, like that. Yeah, I need to investigate what's going on at T equal. I have no idea, que is 2011. I need to find the population here. This is our unknown. And the equation for this curve is given. It's this. So it's super easy. Okay, first of all, I need to find the interval, this interval. How long, so how many years we have. It's obvious que use subtraction 211 minus 1978. I did that and my calculator is 33 years. Basically, this number is 33 years. This time is measured in years in our problem. Okay, plugging in. I need to find population and 33 years is equal to 346 e to the 0.05 multiplication by 33 is the time. And this is the answer I am looking for. 33. Okay, I bring today. I bring the calculator. I don't know if you see or not. Let me know, guys, if you see the calculator. I bring the emulator of the calculator. Let me see here, over there. Do you see or no? Do you see the calculator? Or no?
Yes.
And you see the Jasmine face also, no? Or no?
And Yasmin's face, yes.
It's okay. She's very popular in
Nice
every
one,
class.
Debbie.
Yeah, you are popular and you too.
I'm camera shy.
Okay, let me try to do my best. And this calculator, well, basically is 300. I forgot to copy that in my paper. It's 346 e to the 0.05 times 3. Okay, let's come back. Let's come back to this. To this. Do you see now calculator or no? Yes. Okay, good. You see calculator. Okay, so now you put in the calculator. Look, 346 multiplication. Exponential. Exponential, well, is different in any calculator, but in this calculator, I suppose it's yellow. This. Do you see? And the notation is universal. in any calculator. So you put inside 0.055, no 5, just 5, 0.05 times 33. And close the parenthesis to indicate que finish the exponential part and present. Boom. The answer is 1801.62. I want to check it in my own calculator I have in my hand. This is virtual. It's 346 times exponential 0.05 times 33. Okay, same answer. It's 1,801. You trunk it or you round. Actually, see a population, you can estimate like 1,802. Okay, so I come back to the whiteboard. Let me see, share whiteboard now. Here, over there. Entonces, the answer is 1,802. Because maybe I suppose we are talking about the human being. Maybe, I don't know. It's a exponential population. Any question, guys? How do you feel? And problem number 3. This is problem number 3. How do you feel?
At first it was confusing, but now I get it.
Okay, super. I am happy to hear that. Okay, question, guys. Remember, this is the review. Any question, any problem, I can clarify. Sultana is okay. Clary up. Kendrick. Juan Gomez.
Yeah, it's fine.
Okay, super. Let's continue. Let's continue here. Okay, let's say the number 4 problem is a little bit more complicated because contain two part. Number 4 is more complicated. Why is complicated? Because suppose that you have $15,000. This is a present value. And you invest, which is yield the greater return. That's the comparison. So you compare those things and you compare what is the best option. No? The time is given.
Wait,
time.
Professor.
Go ahead.
I don't see the whiteboard.
Sorry. Okay. Now, Yamin. Yes or no? Answer me, please.
So I don't see it on my end. Let me try signing out and signing back in.
Okay, no, it's okay. Oh, another student. Do you see the whiteboard or no?
Yes, I see the whiteboard.
Entonces your problem, Yasmin.
I see it.
Okay. You try to reload or restart or go back out, go out and in again. Okay? I wait for you. Come on. So let me try to, okay, the money that you invest is 15,000 now. So I need to find the future value, no? Because it's yield the greater return. So I need to find two future values for two conditions. Let me split the paper into parts because we have one account is compounding continuously and interest rate is 9.5%. And 9.5% present in decimal is 0.095. Let me check it out. 2 decimal place divided by 100, 1, 2, yes. And this is compound continuously. Y ahí no, the formula for the continuous is future value is equal to present value e to the RT. Okay, it's similar to to the growth exponential. No? And another hand, we have interest rate, okay, 9.2%. Pero this is no compound. So the interest rate is 0.092. But the formula is different. The formula is A is equal P 1 plus R divided by N raised to the NT. And both problems, the common denominator is T equal 10 years. Okay, now plug it in. A is equal 15,000 times multiplication exponential 0.095 times 10. Okay. And the second one is A equal 15,000, exactly the same, parenthesis 1 plus, I forgot to say something, it's semi-annually. I forgot the classification, semi-annually means que N is 2. Entonces es 0.092 divided by 2 raised to the exponent, que es the multiplication, NT, que es 20 in that case, because N is 2, T is 10. So we need to compute both expressions and compare what the best option. In this case, the best option is when the future value is bigger. Okay, because my money increasing faster. Okay, just let's do it. I want to do in my own calculator. I have my hand. So I put 15,000. And you help me. Multiplication, exponential. Entonces inside exponential I put 0.095 times 10. Close the parenthesis, press enter. I get the answer. Wow. I don't know if it's good or not. 38. You let me know if you get the same answer like me, because maybe I make a mistake. 38, 78, 785.64.
And for
It's
the
okay.
second equation, it'll be 36,874 and 40 because 39 on the other side of the decimal is 39892.
The
Round out
conclusion,
to 8.
you get different answer like me, no? You
Round
get
out
different
to
answer.
8 and you get 40 on the
40.
39.
No, I don't think so. Wait. Let's do it again. I want to do it in my calculator. 15,000. 1530. 1, 2, 3. Multiplication. Exponential, I mean. 0.095 times 10. Close the parenthesis, present. Boom. I get the same answer, Yasmin.
No, I was talking about the other one.
Okay. So let's do it step by step. Okay, this everyone get the answer similar to this or no?
Yeah, so what I did was I plugged in 15,000 in parentheses.
Very good. This is parentheses.
1 plus 0.092 over 2. Close the parentheses, exponential 20, exponent 20 to the 20th power, I meant.
Yeah.
And then the answer I get is 36,874 and 40 cents.
20. Okay. Let's see. Let me check. You're right. I get 36,874. And yeah, you're right. 40 because you round at 39.9. This is 40. This is the second solution. Now it's obvious que the best option is the option que you get greater return is this. Churn. And this is not good. Any question? Any question? Everything is so okay, super. But I want to hear another opinion, guys. Let me know. How do you feel in the solution of the word problems? Okay, this is the typical word problem you see in the test on paper. In the test online, no. The test online, maybe we have another kind using Newton, low cooling, maybe, or half-life, something. So any help that you need, you let me know. No, you email me, send me, remember the screenshot of the problem that you need. I help you. And that's it. And that's it. So I suppose that everything is okay so far? Or no? Okay, we go back again to the question number 5. Well, 5 and 6 is the graph of the logarithm. So we need the paper, the graphic paper. Here. There you go. We need the graphic paper. Here. Entonces, basically, guys, I promise, in the test on paper, you see one graphic of the exponential and one graph of the logarithm. Suppose the first one is easier. The first one is logarithm base. So the function I want to make a graph is logarithm base 2. Ooh, easy of x. And remember 3 point. The famous 3 point in the logarithm is the universal. The universal is 1,0. Remember the exponential was 0,1. But remember logarithm and exponential are inverse function. Entonces you interchange x and y. Okay, so now we're using, for example, the idea of the logarithm base 2. The logarithm base 2 of 2 is 1. And another point is the point 2,1. Okay, remember when the base and the argument inside the logarithm is coincident, the same number, the answer is 1. This is the second point. And when it's reciprocal, it's -1. So we have another point, is the point half, comma -1. 3 point. Let's plot 3 point. Is 1,0 is here. Universal point, because logarithm 1 is 0, regardless the base is 2, 4, whatever. 2,1 is 2,1. Here I plot that point, and half is this, comma -1, is here. 3 point. You want more point? Yeah, we know logarithm base, for example, logarithm base 2 of 4 is 2. Let me plot, pero 3 is enough. Logarithm 4 is 2, look here. And the graph of the logarithm look like that. It's increasing, but increase slow increase. And you need to know by memory also that any logarithm have a vertical asymptote at x equals 0. This is the vertical asymptote. This is important part of the graph. Is vertical asymptote at x equals 0. Boom. End the story. Graph of the logarithm. Any question? And one more detail is increasing function because the base is greater than 1. The base is 2. So it's when the base is greater than 1, I know that it's increasing. The curve is increasing. Okay. No problema. Are you strong? doing the graph of the any exponential and any logarithmic. This is an important objective in this test. Okay, let me erase. You understand everything, erase everything, because we need to do another graph. The graph of the second case function f of x equal, is equation number 5, number 6, sorry, now, is logarithm 1/2. So in this case, similar, except that now the base is less than 1. So si es less than 1, I know that the graph is decreasing. It's decreasing. But again, the same idea, the famous 3 point. I know that logarithm of 1 is 0. Okay, we have logarithm of the base half of 1 is 0. Therefore, the point is the famous point 1, 0, que is the universe. I plot that here. When the base is coincident, when the argument, I know que es 1. So the point is the famous half, comma 1. Half, comma 1, we plot that, half, comma 1, here. Half, 1. And, well, when the element or number inside the argument es the reciprocal, que es 2, que es negative 1. Entonces es 2, negative 1. 2, negative 1 is, we see where 2, negative 1. Y over there. Red color. Over there. Suppose another point extra. Logarithm base half, the 4 is negative 2. Okay, 4 negative 2 is here. Okay, let's say you're connecting the point in the graph. Okay, approximately. I know the fact that we have a vertical asymptote. What curve look like that? And this is the vertical asymptote that any logarithmic function has. This is vertical asymptote at x equals 0. Done. End the story. And this logarithm, suppose that you don't know very well the logarithm 1/2 of 4 is equal, I don't know. Well, one powerful way to do that is by hand or calculator, either way, is, for example, you convert to exponential. The base is half. The exponent is this thing I don't know. Is equal 4. I know that 4 is 2 to the second. Yeah, I know that 1/2 is 2 to the minus 1. Multiplication, this and this, is 2 to the minus 6 is equal to 2 to the second. If we have 2 exponential and the base is the same, then the exponent is the same. So minus x equal 2, que es equivalent to say x equal minus 2. This is one way to do. Another way is one. I never understand very well this part. Okay, no problem. You put in a calculator this idea. You put in a calculator. You change the base. Change the base to a standard base. Entonces you put in a calculator log of 4 divided by log of 1/2. Put in the calculator, the answer is the same. Okay? No problem. So you have no excuse. No, I don't know what is the logarithm. No, you know. But you can find by hand or calculator, the way you prefer. Any question, guys? No? So far it's okay? Okay, let's move on. This is easy part. Wow, super easy. Look, in the test you can see several questions. Is conversion, exponential to logarithm or logarithm to exponential in both directions. Let's do it. So I want to verify or convert to exponential form. Logarithm base 2 of 1 over 32 is equal -5. And you need to change to exponential. Remember the idea. You identification. Who is the base? The base is 2. Put the big 2. What is the exponent? The exponent always is the answer of the logarithm. And is equal to the number inside the argument. Don't. I change from logarithmic statement to exponential statement. Is the answer. Okay. Remember, this is the base. This is the exponent. And this is the result. Result of what? Of the hypothetical exponential statement. Good? Good or not good? Okay. Yay, answer me. Good or not good?
It's
Come
all
on.
good.
It's all good. Okay. Entonces, easy, or relatively easy to continue, no? Okay, here's the question 7. We are doing question 7. I did number 8. The first one I did. You try to do the B and C because it's the same idea, no? Is natural logarithm base 3 of the 1 over 243 is equal to -5. Likewise, logarithm base 2 of the 1 over 1024 is equal to -10. Come on, try. And you activate the microphone and try to help me. Okay, let's focus on the first. B, after A, after C. Conversion, identification, the base, exponent and result, base, exponent and result, base, exponent and result. Come on, effort today.
2 to the negative 10th power equals 1 over 1024.
Okay. Yamin say 2 to the -10 is equal 1 over 1024. This is perfect. Good. And the next one, another participation. No, only Yasmin, please. What is the conversion to exponential form or statement? Come on. I mean, no. Another, come on.
3 to the negative 5th power equals 1 over 243.
Like that?
Yes.
Okay. Guys, do you understand this or no? Come on. Answer me. Are you sleeping? Yes, say yes.
I understand it. I just didn't do it yet on Alex. Once I do it on Alex, it gets in my head all the way.
Okay, David. Another guys, opinions? Alex Peraza, Edward, Nicole, Alan, Sebastián, Roberto Alcalá, Juan Santana, Gabriel Amber, Juan Gómez, Kendrick Crespo, Lariap, Sultana. You understand or no? Answer me.
I understand.
Yes.
Okay. Let's do it in opposite direction. Now it's giving the exponential statement and you convert to logarithmic. Okay, so you have 3 - 4 equal 1 over 81. Okay, B is 2 to the negative 5 equal 132, 1 over 32, sorry. And C is 4 to the minus 3 negative exponent. Daylight negative exponent anytime. Okay, I want to do the first one. The first one is, you put the magic word, log.
Log base
What is
3
base 3, very well, of
1 over 81
is
equals
equal?
negative 4.
Exactly. Okay, the answer in the logarithm statement always is exponent. It's the same. Come on, another participation. No, you mean. Come on, come on, come on, come on. Who there? You are shy or you don't know anything. Come on, Alan, you are good. Juan Gomez is super good student. You are shy, no, Juan? Juan, are you there? Or you are sleeping?
So log 4
Log
and
4.
1 over 64 equal negative 3.
Exactly. Okay. And Lang say number C is log 4 of the 1 over 64 equal negative 3. Look, it's impossible. The base is never negative. The base is always positive. Okay. And number B. Come on, Juan, help me. Let me see who makes something in the chat. Do you see something or not? Activate the microphone. Or you have no microphone. And Juan?
Log base 2
Log base 2
of 1 over 32 equals negative 5.
And make sense of this statement because remember, when you have a contradiction, for example, you have a logarithmic and the base is a number greater than 1 and the argument is a number less than 1. This contradiction always give me negative exponent. When the both are greater than 1 or both are less than 1, so the logarithm is positive. In this case, no. In this case, negative. Well, entonces I suppose that you are clear in that part. Yes or no?
Yes, Professor.
Okay. So let's move on to the next page of the review packet. Okay, this is also easy because basically is you using the property number 5, 6, and 7 to condensing or expand, depending on the problem. No, in the number 9 we have write as a single. Single means only one. Then you have 3 logarithm, 4 logarithm, 1, 2, 3, 4, 5, 6 logarithm. You condense it in only one. Let's do it one by one. A. A is 7 logarithmic base 8 of Z minus 5 logarithm base 8 of W plus 4 logarithm base 8 of B. I need to condense it and only one logarithm should be the base, the same. A, and A. See the base different? No, we cannot do that. Or we need to change the base. Entonces we apply the combination of the property number 5, number 6, and number 7. Property, I want to copy. Property number 5 say that when you have 2, 3, or 4 logarithms and you addition, and the basis is a multiplication. When you have subtraction, is division. And it's important that the positive guy is in the top and the negative guy is in the bottom, no? And the property 6. Sorry. And the property 7 is extremely important is when you have logarithm, only one, but you have power. And the power you put in the front as a fact. So we apply this property together and get these problems. You see, the positive guy is this. And this, you put in the top. So in the top. So I know that we have fraction because we have positive and negative. So in the top, you put z to the 7th power times b to the 4th power. Get this factor go like exponent here. And the bottom we have one guy get w to the 5th power. Get this. And this I am closing the parentheses because this represents the argument of the logarithm when you condense these 3 logarithms in only one. Any question? Any question? No. No, you say, no, I never understand logarithmic. This is a moment to understand. This is your moment. Now repeat again this class. Okay, b is 1/2 logarithm base 2 of a minus 1/3 logarithm base 2 of b plus 1/5 logarithm base 2 of c. And we condense it. What is the only complication? Well, the only complication is if we have a fraction. But it's okay. Fraction is exponent. Entonces, 2 base 2 of. Remember, the guy gets positive is this and this. You put in the top. It's a to the 1/2 times c raised to the 1/5. And in the bottom, I put the negative, is b to the 1/3. Boom. This is one possibility. Okay, so people say, no, well, I don't like this because I don't like the fraction point. Okay. Entonces you convert like a radical. Why not? But it's okay. You leave it like that, 100 points. This is completely extra. See, you, for example, you say, no. I know, okay, this is square root of a times 5th root of c, cubic root of b. It's another way to express the same idea, equivalent. Any question? Wow. Number C is long. We have 1, 2, 3, 4, 5, 6. Wow. Okay, let me erase. Everyone is clear? And the property 5, 6, and 7? Okay. Yes or no? Okay, let me try number C. Number C is, wow, we have 6 logarithms, but some guy is positive and some guy is negative. I know that the positive condensing like a multiplication in the top, and the negative you condensing like a multiplication in the bottom, no? Yeah or no? I am wrong, I am right. Capital A. Okay, make it zoom. Plus, you see, important, any base is 5. See, one base is different to the 5. We cannot do anything except can you change the base. But no, this is not the problem now. Identification, this is positive, this is positive, this is positive, and this is positive. We have actually 4 positive and 2 negative, okay? We condense it in only one, fantastic, only one logarithmic guy. And the top we have x times y times a times b. In the bottom we have y not c times c. Boom. Violence. Question. How do you feel? How do you feel? I'm doing too fast? Or it's a review. Review, I do it fast always. Okay, let's do in opposite direction. I give you a statement in logarithmic, but you are now expand. Is it right? The logarithm as a sum of different of logarithms. Of course. Okay, the complication in this 10 question is, number one, if you have numerical value, you compute that. No indicate, because in this, in question 9, basically inside the argument of the logarithm, we have letter, variable, CAB. In this case, no, we have combination with the numbers. The number you need to combine. Let me try to do the first one, and you help me with the second and the third. For example, 10A. 10A is logarithm base 2 of something, que es 1/60, time W6 time P3. Entonces, you write as a several, no 1, 2, 3 logarithm. The first logarithm is logarithm base 2 of 1/16 plus 6 times logarithm base 2 of W. Leave it like that because it's variable. In this case, no. In this case, I need to compute that part. Plus 3 logarithm base 2 of P. ¿Es the final answer? No. It's not the final answer because the numerical mandatory, you need to compute the number associated with this. So I need to compute logarithm base 2 of 1/16. Okay? Suppose that I have no idea. Remember, there are two ways, calculator or by hand. I want to do in both ways. Calculator, I put X because you don't know. You convert this statement to exponential. The base is 2, the exponent, I don't know, is equal 1/16, but I know the 16 is 2 to the 4th power, no? And reciprocal is negative exponent. So it's equivalent to say 2 to the -4. In this case, we have 2 exponential. The base is the same. The conclusion is X is negative 4. Okay, it's a one possibility. Another possibility, suppose that I never understand this idea. Okay, no problem. You convert using the chain of base formula. You put in the calculator logarithm of base 2 of 1/16 divided by logarithm of base 2 of 2. Well, in this case, you don't apport anything. Well, you put it in the calculator. So wait. But you put no base 2, so it's hello, what the hell? Look, it's standard. Standard logarithm. Because I use the calculator. You put in the calculator and you get the same answer. You can verify if you want. So what is my final answer in this problem? Oh, my final answer is similar to this, except that you replace this by -4. -4 plus 6 logarithm of base 2 of W plus 3 times logarithm of base 2 of P. And close on the box because this is important because it's the final answer. Any question, guys? Any question? Do you understand very well this kind of problem? It's completely the opposite idea. Is you have one logarithm and you break it down, decompose, expand in several. And the numerical part, mandatory, you need to find the value. That you have no excuse, okay, because I don't know what is the logarithm of base 2 of the 1/16. Or by hand or calculate. You can do that. Okay? Okay. Now I need participation in B, for example. Let's do in B. Let's do B. Let's do B. B. B is logarithm base 3. Logarithm base 3 of 81 a square b6 divided by c4 d5. Well. We have 1, 2, 3, 4, 5 guys. Therefore, when you finish the problem, we have 5 logarithms, right? And be careful, the numerical logarithm, well, is necessary to compute that. Don't indicate like a logarithm base 3 of 81. No, we need to compute that. Okay, and I hear you. Participation, come on. How you expand this logarithm using 1, 2, 3, 4, and 5 logarithms? What rule? What sign? What's going on with the exponent? Go ahead. Go ahead. Come on, participation. Participation. Juan, definitely you are sleeping, Juan Gomez? Oh no. Juan Gomez, answer me. Wow. You are not there. You hear me or no? A ver, Kendrick, do you hear me or no? Kendrick? Kendrick? Wow. I suppose the student get inside the class and continue sleeping at home. Wow. Wow. Alan. A ver, Alan, I don't hear you very well, Alan. Come on, help me.
So it's log 3, 81.
Slow down. You're right. Log 3, 81. Keep going. Plus or minus? I don't hear very well.
Can I write it on the chat? Because my microphone doesn't work today.
Oh, okay. In the chat, you send me the expression. Let me check in the chat. In the chat, I check in the expression. Alan is typing.
And then plus
something.
Log 3 B Q no 6 B to the 6.
B to the 6. Pero entonces now the exponent, you leave it like that or you put it in the front? What is the best way?
Yes, I think that worked.
So you want to expand completely. I recommend put the exponent in the front using the property number 7. Okay?
Yes.
And you forgot A? Oh no.
Yes, A, and then so I put log 3A square.
Excellent. Like that? We're doing well? Minus. How do you know que es minus?
Because they divide, so it's become minus.
Exactly. So 4 times logarithm base 3 again of C, no?
Yes.
Minus 5 logarithm base 3 of D. Okay, and leave it like that, the answer, or you compute that part? When there's numerical.
I think you can complete it.
Now what is the answer? What is the logarithm base 3 of 81? No idea? What way you prefer? Calculator or by hand?
Calculator.
Okay, let's do it. So you put in your own calculator, logarithm 81 divided by?
Yes, it's equal 4.
Exactly, it's equal 4. She said it's equal 4. And my final answer is just replace this by 4. 4 plus 6 times logarithm of base 3 of B plus 2 times logarithm of base 3 of A minus 4 logarithm of base 3 of C minus 5 logarithm of base 3 of D. This is my final answer. Okay. 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 And that's it. And that's it. And that's it. Any question? End the story. Any question? Thank you, Alan. You're good. Now,
Thank you.
no problem. Let's see another problem. Then see, I need another participation. Okay. I need to feel. Okay, you understand? Okay, another participation. Who there? Who there? Who there? Next one. No Yasmin, no Yasmin. Yasmin, I am boring to hear. Alejandro, Hilar, maybe. Sultanat. Alejandro, are you there? Alejandro. Alejandro, activate the microphone. Say yes or the chat. Sultanat. Guys, you don't answer me. I put out the classroom, the virtual room. Alejandro, are you there or no? All right. Answer me. Edward Clear. Okay. Edgar Quintana, are you there? Edgar? Davey, yes. Raria Pervais, are you there? Edward? Nicole? Sebastian? Okay, Nicole, yes. Nicole, could you help me? Could you help me in this problem, in the next problem? Or no? You understand or you don't understand, Nicole? Nicole? I don't, why? But you don't understand, Nicole? Oh, let me see what's going on with Nicole. Nicole said no. You don't understand, Nicole? Entonces, what is the reason that you don't ask me a question, please? Okay, okay. What part you don't understand? It's important. Because this is not a lecture, it's a review. Entonces, I need to understand what part you don't understand. Nicole, what part you don't understand? Activate the microphone. You have microphone or no? What part? The property? What property you need to using? Nicole. Oof. Guys, horrible. Okay. Okay. Let's do number C. C is, I copy. Logarithm base 5 of 625 x to the 5th power, y to the 6th power, divided by z to the 6th power, w squared. The problem say, write the logarithmic as a sum or difference of logarithmics plural. So you expand using 1, 2, 3, 4, 5. You copy logarithm base 5 of 625 plus y plus, because it's multiplication, 5 times Logarithm of base 5 is super easy of x. Plus again, because it's time, multiplication, 6 times. The exponent you put as a factor in the front. Logarithm of base 5 of y. Now minus, because it's in the bottom, denominator is negative. It's a property number 6. Is minus what? No, minus 6 times, again, logarithm of base 5 of z. Finally, minus 2 times logarithm of base 5 of w. And leave it like that? No, because the numerical part, you have to compute, of course. The variable part, no, leave it like that. In this case, I need to compute logarithm of base 5 of 625. You can use a calculator. You put in the calculator like that. Logarithm of 625 divided by logarithm of 5. So we're using in our calculator a standard logarithm, que es just log, que es the basis 10. And the answer again is 4. So the final answer is 4 plus 5 logarithm of base 5 of x plus 6 logarithm of base 5 of y minus 6 logarithm of base 5 of z minus 2 logarithm of base 5 of w. This is my final answer. Okay? Okay. Nicole, now you understand or no? Hey, Nicole? Nicole Delgado. Do you understand now or no? Nicole? Yeah. Okay. 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 Let's continue. Oh, this is a piece of cake. Next one is a piece of cake. It's a piece of cake. Look. Look. Evaluate to 4 decimal place. Evaluate for 4 decimal places. Now we need to use a calculator. Logarithm of base 12 of 23.5. Entonces now I make a decision in the calculator by using standard, no? Standard logarithm. Okay, let me try to show you how you put in a calculator. Let me see. Do you see the calculator? Oh no. Do you see or no? No? Let me know, guys.
Professor, it just looks like
I
a
don't see the
black box. We can't see the actual numbers.
Answer my question. Do you see the calculator or no? No? I need to share the screen for the calculator. Yasmin?
No, Professor. I don't
No?
see the
Okay.
calculator.
I understand. Relax. It's exactly my question. Now you see? Now? You see calculator?
Yes.
Okay.
I
So
see it now.
excellent. So now, well, this calculator is weird. Maybe your calculator is easier. We have no LOG. We have only LM in blue color. Look, but the same. It's a standard also. So you put a blue LM of 23.5. Close the parentheses. It's important that you close the parentheses. Divided by LN again. 12. In that case,
We
we put in
get 1.2704.
Excellent. 1.2700405.
05, I meant,
05.
because the
Ex-
7 rounds it up.
Exactly. Exactly. Let me notice. Okay, for example, the number inside the logarithm of 23.5 and 12 both are greater than 1. And the base of this natural logarithm is e is 2.7. But in this case, both logarithms are separately are positive. And positive divided by positive, the answer is positive 1.2705. Correct? Correct? Good. Let me, okay, so you help me to the next one. Okay, es logaritmo. I copy in my paper. 528, the logaritmo 1/2 of the 44. Okay, so I want to come back again to the calculator. Do you see calculator, right? Or no? Do you see in that in this moment you see calculator or whiteboard or both?
I see the calculator.
You see calculator only. Okay. So let's do it the next. Let me clear everything. Clear. Boom. You put LOG or LN, whatever you want, of the 528. Close the parenthesis, divide by LOG or LN, whatever you want. In this calculator, we have LN only 5. In this case, both numbers 528 and 5 are greater than 1. So you expect positive value, positive divided by positive is positive. The answer is, this is the exact answer, and the approximate answer is this. 3.8952, no? Yes or no?
Yes.
Okay. Okay, let's do the last one. The last one is ln or log, either way, of the 44, que is greater than 1, divided by ln or log, your own calculator, of 1/2. 1/2 is 1/2.5, decimal or fraction, either way, divided by 2, maybe like that. Boom. In this case, wow, look at that. 44 is greater than 1. This logarithm is positive. And logarithm 1 is negative. Entonces, the answer que you expect is positive divided by negative is negative. I expect negative value in this example. You press enter. Boom. This is exact answer, but the approximation is -5. -5.4594, right? 1, 2, 3, 4 decimal place. Good or no good? Piece okay or piece of rock? Good or no good? Okay, let me share again the whiteboard. Yuli, whiteboard. Cancel. Whiteboard. What's going on with the whiteboard? This guy, yeah, sorry. You see whiteboard now? Okay, you see or not?
I see it now.
Excellent. Let's move on to the complicated part. So that everyone understand the application, the calculator change base formula. Number 11 question. Okay, let's move on to 12. 12 is 1/3 raised to the 2x plus 5 equal 9 raised to the x plus 3. This is the exponential equation. Remember, there are two kinds of the exponential equation. The exponential equation in which you can solve it without logarithm, without using logarithm. because you can manipulate both sides in order to express in the common base, or another case impossible. When it's impossible, mandatory, you need to use a logarithm. But in this case, I suppose that we can manipulate both sides in order to express in the common base. Yes or no? Because in one corner of the piece of paper, you copy 9 and 1/3. And 9 is 3 to the second power. And 1/3 is 3 to the minus 1. So the common base is 3. So you replace, no 1/3 anymore. It's -1/2 exponent. 2x plus 5 equal 3 to the second power, x plus 3, something like that. Now multiplication. You apply the property for the exponent. No? When you have different level of the exponent, you multiply. So actually it's 3 negative 2x plus 5. I put in a parenthesis because this -1 multiply everything inside this here. And 2 multiply this guy. Entonces es 3, 2 paréntesis, x plus 3. Crucial moment. If we have 2 exponential and the base is the same, it's because the exponent is the same, and you copy minus parenthesis 2x plus 5 is equal to parenthesis x plus 3. And magically, we convert the exponential equation to linear equation. Okay, I apply distributive is minus 2x minus 5 is minus multiply everything equal 2x plus 6. Ready. Entonces, let me see, -5 stay here. Final -6 I move to the left, 2x stay, and plus 2x I move to the right. It's a -11 is equal 4x divided by 4 both sides, because my goal is solve for x. The final answer is -11 over 4 equal x. And don't be scared, because the answer must be positive or negative. Remember, the exponential equation or the exponential function, the domain is all real numbers, so we have no problem. Okay, you checking, no. Always the answer is positive or negative. The domain of the exponential is all real numbers. So accept any solution, positive solution, negative solution. Doesn't matter the solution. Super. How do you feel? Exponential equation, easy exponential equation, in which you can manipulate both sides in order to express the common base. Okay, let's do one more and stop today because we have time. Okay? We have time. Remember, guys, I am available for you anytime. When you have some problem that you don't understand, because in Alex, some problems are a little bit hard. And so now you email me and I try to help you, right? One more and that's it for today. Because I realize that some students don't pay attention today. Okay, only Yasmin and Dan, Davey, and the rest is sleepy maybe, no? Or not here. Number 13. This is another example in which...
Professor, maybe the other students got caught on the highway.
Oh, maybe. Maybe, you're right. Okay, entonces in this case, it's another example in which is similar, no? Because 125 is 5 to the cubic power. And 1 over 5 is 5 to the -1. So you replace, no 1/5 anymore. It's 5 raised to the -1. X plus 2 is equal 5 cubic raised to the x power. One more time, multiplication, different level of the exponent is 5 negative parenthesis x plus 2 equal 5 times 3 times x, 3x. Okay, if two exponential function on the base I create artificially is the same, then the exponent is the same. So minus x plus 2 is equal to x. Linear equation. Distribute the property. Minus x minus 2 equal 3x. Minus 2 is equal 3x, 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 3x plus x, no? Because I moved this x to the other side. And minus 2 is equal 4x. Wow, nice. I like that. Divided by 4, both sides. And reduce the lowest term, negative 1/2 equal x. And no necessary verification. So the exponential equation is nice. Exponential equation maybe have positive, negative, doesn't matter. Because the domain of the exponential is already a number. Is already a number, the domain of the exponential. So you accept in the exponential equation, accept positive, negative, 0, whatever. And the logarithm, no, logarithm speaking, but the logarithm we discussing next time. And we discussing next time the complicated part. So now we're discussing the exponential equation que es impossible doing that way. Entonces you mandatory need to apply logarithm both sides, more complicated, and logarithm equation. Okay? Okay, guys. Entonces I appreciate so much your attention. Thank you, Amin. Thank you, David. Thank you, online. Appreciate
Have a good day.
You too. Immediately I send the video. Okay?
Thank you.